This is the third video under the chapter lenses, and here we'll be coming on to the diagrams, which is the main part of the chapter. But honestly, if you understood the three rules that we just did in the last part of the last tutorial, you'll be able to do all of the diagrams on your own. There won't be any need of any other help. Now, I can't really teach you much in these. I can only give you a few terms which you need to remember, and also just one simple, I don't know if it's a trick or just a way to remember a few things. I can just tell you that much. The rest, unfortunately, you guys have to do on your own. And the main part of the chapter is not the diagrams, but it's actually three rules. Those are more important than you think they are. They might be just a little box on the bottom right or something of the page, but that's the main part of the chapter. And honestly, if you understand that, you'll be able to do all the diagrams, convex, concave, anything. So, firstly, I need to tell you what is real, what is virtual, what is erect, what is diminished, what is magnified, all those terms, what is inverted as well. So, firstly, starting with real and virtual, you know that in, say, a convex lens like this, you have rays coming in like this. Say you have two parallel rays, you know they're going to meet at f2. Here you can see these two rays actually do meet, like physically they meet. This is always called real. When the two rays meet, they actually meet, they come in contact with each other, whether it's on converging, diverging, we call it a real image, then they form a real image. On the other hand, if you have a concave, you have parallel rays, they go like this, but remember they just appear to meet at f2. But this is if you just place them backwards. They appear to meet, they do not actually meet. They're actually physically going this way, going away from each other. So when they form this image at f2, this is called virtual. Now, in most of your diagrams, the one thing that is common to, I think, all except one is that when you take your object on the left side, you're going to take it as a sort of stick like this. You're going to take 2 points, say like A and B over here. Your lens is here. I'm not doing which one because it can be any over here. Usually, the best way to do this is take one that is parallel to the principal axis, because you know that's going to pass through or appear to pass through f2, or that's one of the rays, and the second one you take usually through the optical center that goes undeviated. Then you see when both of them meet or appear to meet. That's the general way how to do it, and you seem to follow your rules after that. So if you look at it, if your image forms like this, just say it's like this. I haven't done any real calculations or anything over here. I'm just drawing a random line. You can see that A and A will actually be formed. Your if you draw a ray from A, I'll take another color for that. Say this is, sorry. Say this is a ray traveling from A. It goes undeviated through the optical center. Meanwhile, for B, the B rays come over here. So you can name these 2 points B dash, A dash. So you can imagine that if there's a person, say AB is like a person with A being the legs. What will happen is that the legs will come like this over here. It'll actually get inverted. So this is called inverted. And on the other hand, if your B somehow comes up like this, you have another scenario, then you'll form A dash and B dash like this, which will be the normal thing, and that'll be erect. Okay? And Of course, then there's diminished and magnified, highly diminished, and that just depends on your diagram. And some of those you just need to learn up, because there's no way to tell whether it's magnified or highly magnified. Those need to learn up, but what it basically means is that at times your image will be either smaller or larger than your actual object. Say this is it, and what you get is something like this. This is your original man standing here, this is the object, but what you get is an inverted man who you can see is clearly bigger than the real one, the actual original one, the object. So the image and the objects, we call the image magnified, and here you can see it's inverted, but at the same time it's real because the rays are meeting. So this is just how you figure out what are the properties of the image form. And honestly, the best way to do this is to just take a copy, a rough copy or something, take a piece of paper, and in order to prepare, just draw all of them on your own. Just try and apply the rules, and it'll happen. You'll see after a bit of practice. The uses, unfortunately, there's only a certain amount you can apply. The rest you need to learn up, because a bit you can figure out that this will come under concave, this will come under convex, but now will it come beyond to f1, will it come between f1 and 2f1? To distinguish that, all you can do is just learn that up. So that's it for drawing the diagram. For concave, it's the same thing, except your rays will diverge like this. They just appear to meet at the back. Again, usually the virtual, erect, and smaller. Not usually, but always, at least in your syllabus, virtual, erect, and smaller than the object. Now, if you have any doubt over here, you can tell us. We'll tell you whatever you want. But right now, I can't do all of them because it's up to you guys to do it yourself. There's no teaching that I can do over here. So the next thing is power of the lens. I've taught you focal length, say FL. All that power of a lens is 1 upon focal length, where focal length is in meter. This is power, and this power is measured in a unit called diopter. This is really important. It's not in meter to the power -1 or anything. It is technically that, but the unit you say is diopter. There's also in your books a diagram of a whole explanation of the magnifying glass. If you understand the lenses, the diagrams, you'll understand that on your own. You can go through the construction, the whole working. But again, if you have it out, tell us. Then the rest, there's also, in my book at least, they've given a bit about persistence of vision, part of accommodation of the eye, least distance of distinct vision, focusing. All that, honestly, you'll do in bio as well under nervous system, or you would have done it. So there's nothing new to teach over there. I think you guys know it already, but that's not really important when it comes to physics. But just know that the eye can do a lot. It can look at things far away, focus on things that are very nearby. But when you talk about very nearby, it's only up to a certain point, and that's the least distance of distinct vision. And also, there's persistent vision, which means that every image that you see stays in the brain for I think 16th or 1/10, 1/7. I'm not sure. You could check your books. 1/10, I think, for 1/10 a second. So if you have more than 10 images a second, you'll see it as motion, which is how all movies and animations work. So I think that's it for this chapter. Again, I think the best way to do this is to just take a rough copy and draw all the diagrams so that you get all the rules in your head. And in this chapter, the only questions you'll be asked, I think they'll be mostly in section A. They'll be based on, they'll give you a description of an image form, like, for example, real, inverted, diminished. And you just need to tell them For example, which lens are we using, what's the position of the object, what's the position of the image, draw a diagram for it or complete the diagram and give an application. That's all you need to know. And for that, again, the best way, practice and know the three rules. But that's it for this chapter, and next time we'll be back with, I think, return to syllabus.